to do stoichiometry, you want to have a balanced equation. And then it's kind of like a puzzle. It's kind of like a puzzle. And what I think I would do if I were you, I would actually try to use a shortcut to fill all these in, and then do the factor label to see if you get the same answer. Or if you can do the other way around. If you want to do this first and then check it with a shortcut, you can do that too. But let's take a look at this right here. We also wrote out some things called molar masses. And we know we're going to use them anyway. And so what's the molar mass of lithium hydroxide? And if you're having trouble with that, you're going to have trouble with the whole chapter, okay? So tell yourself, am I really good at the molar mass of lithium hydroxide? Have you guys, did I ask you, didn't we do this or not? Did we do molar masses last Friday? Did we do that? Did we write molar masses somewhere? Okay. All right, so here's this one, and here's this one, and here's this one. See if you can tell me how many grams it takes to make a mole for each of these. Who wants to take one? Who wants to pick one? Anybody want to pick any of these? Which one, Dan?
23.9 for lithium hydroxide.
Okay. 23.9, even 24 would probably be okay on that one. 23.9 grams. And how does he get that? It looks on the periodic table. And 1 lithium, 1 oxygen, 1 hydrogen. Does everybody know how to do that? Does everybody have a periodic table in front of them? Okay, so you have 6.9 plus 1, that's 7.9, plus 16, and does everybody get that? Okay, what's the molar mass of carbon dioxide? Who wants to try that one? Somebody different. And by telling me this, all right, Layla, you got it? You weren't even here, you got it? What's the molar mass of carbon dioxide? 44 grams. Okay, now lithium carbonate, Li2CO3, it's got 2 lithiums, 1 carbon, 3 oxygens. Somebody new. Get your calculator out. What is it? Nice. 74 grams, and water? 18 grams, okay. All right, now we're actually ready to do everything. We're ready to do the whole problem. And did we, on Friday, did we use this as our example, or did we use something else as our example? Is that what we did? I'm trying to remember. Did we do these? Is that what we did on Friday? Is that why I have these here? So I did some other reaction, didn't I? Okay, so this was your homework, wasn't it? All right, so let's do, would you like to do shortcut first? You want to do long cut? Okay, let's do long cut first. Okay, long cut means factor label. You look up here, what's the only information they actually give me? That's it right there. So I'm hoping that everybody wrote that right there. Is that okay? So that's going to be my given. And you can't be lazy. You have to write the whole label out, okay? Because if you don't, you'll get lost. Now, I tried to tell you this when I first taught this to you a week ago. You can't go from grams of that to grams of that because there's a tree in a way, right? But what can you do? You can go down in the mole world, go across, and come back up, can't you? So, if you can say it in words, you can do the problem. All right, Madison, in words, what are you doing if you go from here to there? Well, in words, I'm changing grams of what? Can you close that door for me, please? I'm sorry. I'm having trouble concentrating myself. So, Madison, you were changing grams of lithium hydroxide to what? Okay, so that's my given. I want to get rid of grams of lithium hydroxide. I want to change it to moles of lithium hydroxide. Okay, now, what do you know? What's everything you know about lithium hydroxide in the mole concept? Let me see if I have some space here. 1 mole of lithium hydroxide equals, who wants to help me out here? And by helping me out, you're helping yourself out. Zach, you said you needed help on this. Tell me everything you know about lithium hydroxide. 1 mole lithium hydroxide is what? Okay, all right, I'll do that over here. It's what now? 1 mole. 1 mole lithium hydroxide is what? Okay, what is it? 23.9 grams. It's also 6.02 times 10 to the 23rd formula units of lithium hydroxide. Okay, everybody get that? So now, how do we do this problem? Look right here. What do I need? I need so many grams of lithium hydroxide equals so many moles. 1 mole lithium hydroxide equals 23.9. Now, go ahead and put that in your calculator. Yes. Okay, now, again, 2 months ago, somebody took mine, they didn't return it, otherwise I don't have one to give you. Do you have a phone? Take his phone out. Phone. If I had an extra one, I'd give it to you. If you could go borrow one, I just don't have one to give you, I'm sorry. Yes?
I don't have mine either, so can I use my phone?
You don't have what?
I don't have my calculator.
You can use your phone.
Okay.
Hey, can everybody try to get a calculator? Without this whole week, you're going to use a calculator every day except Tuesday. Okay, I won't see you. But try to get a calculator. If you have to borrow one, get one. All right. So now, what I'm going to do is, instead of putting equals here, I'm just going to stop, put it in the calculator, and see what you get here. Who have I not called on yet? Isabella, did you do this yet? What'd you get? 41 point what? Okay. As long as you have at least 3 sig figs, I'm okay. So if you want to put 4 sig figs, you're okay on that. Get that? Is everybody getting something like that? Okay, if you happen to round that off to 24, you'll be a little different. I'm okay on that. I'm okay with that. I'm looking at your eyes. You're all right, right? The question says, how many moles are given? Oh, you know what? Now we can put equals because we did it right. Just raise your hand. You said, no, I didn't get it. I didn't get that. If you asked me to do it on a quiz, I couldn't do it. Okay, now we're going to move on, all right? What's the next question? How many moles of carbon dioxide? They want to find this guy, right? Remember the moles live down underground? That's why I always find moles, the way I organize the problem. So what am I going to start with my given? Okay, I could start with this as my given, and I had to do that step again, do another step, or if I know that's correct, I'm going to use that as my given. And that's moles of lithium hydroxide. So that's my given now. Okay, now, let's call on Julia. Julia, in words, what are you trying to go from what and convert it into what? Say it in words.
So you're converting 41.84 moles of lithium
Moles of lithium hydroxide into what?
moles of
Yes. And if you can say it in words, you probably could do factor label, can't you? Now, what label has to go away down here? And what label did you say you want to convert it into? You said moles of carbon dioxide. Now, we did this about 4 days ago. Well, actually 5 days ago, but you've never done this before this chapter. You've done this. You did that. You were certified on that kind of stuff, but you've never done that. So what is it when you go sideways in the mole world? Let's see if the weekend to take it out of you. When you go sideways in the mole world, what numbers do you look at? Yes. So watch. The coefficients are 2 and 1 down here. It says in this balanced equation, for every 2 moles of lithium hydroxide, you only get 1 mole of carbon dioxide. Are you okay on that? Put that in your calculator. Let's see, who had an answer one yet? Kyle, you have an answer one. What's 41.84 divided by 2? .92. Is everybody okay on that? Now, I could put equals here and put 28.92 and then start another problem here because it asks for 2 things. What's it ask for? Moles and what else? Can you help me? Wow. I'm sorry you had that. And there's only 2 high school classes down here. Everybody else is upstairs. Oh well. That used to be you though, right? That was you guys, right? A couple of years ago? Oh yeah, that was you. Okay. Now, instead of putting equals here and starting the problem all over again, why don't I just start right here? I'm already here, aren't I? This right here, I'm here. Now, in words, let's see if, Sierra, you weren't here, but if you can tell me the answer here, you're way ahead of the game. What am I changing from what to what? Don't give me numbers, just say what? Moles of? Yes, yep. Okay, now, I know that I'm already in moles of CO2 right here, right? So get rid of that and change it to grams of CO2, because that's what you told me in words. Now, I'm going to do the same thing up here that I did with lithium hydroxide. What's everything you know about carbon dioxide? See, I'm called on Layla. Layla, tell me everything you know about CO2 and the mole concept, because you're certified. Say it real loud.
Equals 6.23.
Uh-oh. Molecules, it's non-metal, isn't it? Equals?
44.
Yes. And the new thing you learned in this chapter has to do with that blue box. For a gas, if you're a gas, and this is a gas, what's the new thing you know? Who remembers this one? Do you remember this one? 22.4 liters. Okay, now I only use that for gases. You get that? Notice I didn't put it up here because that's not a gas. But I might have to use that a little bit later. Okay, so now go down here. I'm going to change moles and grams. These have to be equivalent. 1 mole of carbon dioxide is the same as 44 grams. Okay, put that in a calculator. Is your phone working? Okay, can you tell me what you get here? So you already did this and got this number, right? And you left that in a calculator, and now all you're going to do is multiply by 44. 920 point what? Okay. Is everybody getting something like that? Everybody's getting something like that? Okay, good. Are you catching on? Are you catching on? There's a system, isn't there? There's a system that says, I can do these. All right, and then at that point, then we can go ahead and put it out 120.5 grams of CO2. Now, if you guys did this for homework, is that what happened when you were doing your homework, or did you get stuck? Did you get stuck? What about now? Would you get stuck again? Okay, tell me, May, which part?
I just don't understand, just kind of like the process of it. Like,
Okay, so
like if I were to have to do it on my own, like I would do it.
okay, let me start again. Watch right here. This is the only thing that was actually given to me, right? So I know I can't go from grams of that to grams of that. There's a tree in a way, right? So I have to tell myself, do I know how to change grams of lithium hydroxide into what? Moles. And we did that last chapter. Remember the mole concept? And so go ahead.
And then it's the second problem.
Okay, how about the first one though?
I get how to go from grams to moles.
Excellent. Okay, then now I know where we're at. This is something new. What's new is when you go sideways in the mole world, you don't pay attention to these numbers, you pay attention to the coefficients. This balance equation says for every 1 mole of carbon dioxide, you have to start with what? And that's where I got those numbers. And that's a vocabulary word on the test. It's called a mole ratio. The mole ratio, or the ratios you make with the coefficients like that. God said, not me, it wasn't me, God said, hey, if you start with 2 moles of that, it'll only react with 1 mole of that. I didn't even do it. God did that.
How did you know which one was at the bottom?
Okay, good question. Good question. I started with this as my given because I had figured that out up here, didn't I? So I wrote that down as my given. What does it say? Moles of lithium hydroxide. Isn't this lithium hydroxide? Isn't that moles of lithium hydroxide? Now, in order to get rid of moles of lithium hydroxide here, what has to be down here? Moles of lithium hydroxide. Otherwise, it won't cancel out. They have to cancel out, right? And then you said you wanted to change moles of lithium hydroxide to moles of carbon dioxide. That's what gave me the label here. So now, after I cancel everything out, my answer will be in moles of carbon dioxide, and I write that down. Now, instead of doing another whole problem altogether, I said, all right, now I'm in moles of carbon dioxide. I'm going to change the moles of carbon dioxide to what? Okay, and see this label here? What has to go down here? And what goes here? And that's where I use that stuff there. Remember that? All right, so we'll do a couple more, okay? Now this next one, it says how many liters of carbon dioxide. And so what I'm going to do is, I've already figured this one out, so I'm going to let that be my given. 20.92, say the words. What are the words here? What is that called? 20.92 what? Everybody. Moles of what? Okay, that's my given. Now, what's my goal? Change moles of carbon dioxide all the way to what? Liters, yes.
So could we start with grams?
You can start here,
Or
and you just have to repeat everything you've already done.
could you start with like the grams?
Yes, yes. I can do it both ways. I start with moles. You said you want to start with the grams. I'll do that. I'll do it both ways, and we'll see what happens, okay? All right. Now watch the labels. See, factor label is really your friend. Factor label makes it so you can help you do this problem. This label here has to go away, moles of carbon dioxide. I'm going to change moles of carbon dioxide to liters of carbon dioxide. All right, where do I get my numbers? Let's go over here again. And what do you see? And a gas, if you're a gas, you get to add that to, don't you? Now, tell me about these. Ready? Oh, 1 mole of carbon dioxide is the same as what? Oh, 22.4. And I can do that. Now, use grams. Let's do the same thing. Ready? You have to get rid of grams of carbon dioxide, and you want to change it to liters of carbon dioxide. I'm okay with that. Now, tell me the numbers that go in there. Where do you see grams of carbon dioxide?
I said it from the last problem.
No, don't do that. You have to use equivalents. This has to equal that, doesn't it? Aren't conversion factors always made from things that are equal to each other? So if you want grams of carbon dioxide, you got to go up here. See that? Oh, now what I'm doing is, that was my given. See that? That's grams of carbon dioxide that you did that. See that? But now to convert it, grams into liters, I have to use equivalents, things that are equal to each other. So, okay, so guess what? 44 grams of carbon dioxide is the same as 22.4 liters of carbon dioxide. And you know, believe it or not, you probably don't believe me, but you'll get the same answer, whether you do it one way or another. And so what is that answer? What do you have for the answer here?
I got 468.6.
458?
468.6.
That?
68.
Oh, 468.
Yeah.
0.6. Is everybody getting that or not? You know? What are you getting? Did you get that? You didn't?
I got 0.2. I mean, like 468.
If you got 468, you're fine. There's a little bit of rounding involved, isn't there? There's a little bit of rounding involved. All right, what do you think? Okay, let's try the next one. How many moles of lithium carbonate are produced? So they want me to find that. So what are you going to start as your given? Which one do you want to start as your given? What do you think? Delaney, I haven't called you. What do you want to start as your given? I want to find this, but what do I start my problem with? Of what? I can start right here, right? If I start here, in one step, I'll have the answer. So 922 what? Yeah, I'm sorry. Good catch. Moles of CO2, right? All right, Delaney, in words, what are you trying to convert? Moles of CO2 to what? Nice. And that's called lithium carbonate, isn't it? Okay, now, where do you get the numbers when you go sideways in the mole world? Delaney. If you're not sure, ask May.
And the coefficient.
Yes? All right, look up here. What do you see here? For every 1 mole of that, you get what? 1 mole of that. Now, some of you now can understand how the shortcut works. Shortcut works because this is going to be a matchy-matchy, isn't it? You can put that in your calculator. You're going to get what? You're going to get that, aren't you? Now, because it asks for 2 things, it asks for moles and grams. Instead of me writing a whole nother problem, I'm just going to say, I already know that's moles. Moles of lithium carbonate, right? So, what am I trying to do? Let's see. Go around the room again. May. What am I trying to do? They want me to find moles of lithium carbonate, and we did that. And then it says find grams.
So grams, you're gonna go up.
What?
out of the mole, right?
Yeah, what label has to go away?
You're trying to get the mole labels to go away.
Moles of lithium. Isn't that right? Lithium carbonate. See, that has to go away, doesn't it? So moles of lithium carbonate has to go away. And what are you trying to convert it into, May?
Grams.
Of what?
Lithium carbonate?
Yes. If you can say it in words, you're probably going to understand how to do this. Now, what do we get? Where are you going to get these numbers from? And we can make it up here. By now, a lot of you can do this in your head. Is that right? Can a lot of you do this in your head? 1 mole of lithium carbonate equals 6.02 times 10 to the 23rd. This is an ionic compound, says formula units equals 74 grams of lithium carbonate. Now, notice I didn't put the 22.4 because lithium carbonate's not a gas, is it? So I can't put the 22.4 liters. All right, so here we go. 1 mole of this equals 74 grams. And we did that last chapter. Now, put that in a calculator and tell me what you get. Anybody got it ready already?
Could you move it a little bit?
Okay, sorry. Somebody can tell me this right here, your calculator should still have this number in it. Should have 20.92 in it. And then you end up multiplying by 74, don't you? Isabel, what you got? Wait, one more time. 6048. Oh, 16.8. 16.8? Or 60.8? All right, it's 20.92. And then these ones aren't gonna change anything, times 74. 60. Oh, 1548. Is there a decimal? Is that it? 1,548? Okay. Okay. Is that right? Okay, good. All right, now, we're getting close now. We're getting close. Now, ready? How many moles of water are produced? Okay, what do you want to start as your given? They want you to find that, don't they? I'm going to start right here. What's the bad news about stoichiometry? If you make a mistake right here, all your numbers are wrong, aren't they? You say, I'm not going to make a mistake. I'll be careful. All right, I'm going to start that as my given. 20.92 moles of lithium carbonate. May, just in case you weren't sure about that, I could have started with any of these as my given, but I'm going to do this. It's going to be easy for me to go from here to here. So I'm just going to start with that as my given. Okay, now, let's go back to Daniel. Daniel, in words, what am I trying to convert into what?
Trying to go from moles to moles.
Of what?
Moles of lithium carbonate.
Yes.
To water.
To moles of water or grams?
Moles.
Moles of water. And since you're going sideways, where are you going to get your numbers from?
Coefficients.
Ready? For every 1 mole of that, it'll produce 1 mole of that. There you go. Now, if we put that in there, that's why matchy-matchy works, by the way. Everybody get that? And I have one more thing to do. It says change it into grams. Okay, so what we're going to do here, and Zach's going to help me. We're going to try, tell me in words.
Gonna go from
Of,
moles of water.
yes, moles of water to what? Yes. Now, what do you know about water? Can you say it in your head? Can you tell me the equivalents in your head? 1 mole of water is what? 18 grams, all right? And we're not using the 6.02 today, right? Okay, so 1 mole of water is 18 grams. There we go. One more calculation, and we'll see what's going on. Zach, do you have that one, Zach? So 20.92 times 18. I'm sorry, 0.5 what? 5, okay, all right. Now, I have one more thing for you to do, okay? It doesn't take that long, and when you do the test, you're gonna do shortcut. See, I might have you do this on the quiz, but on the test, everything's gonna be shortcut. But how do you know you didn't make a mistake? So what we're gonna do is, we're gonna add the masses of the reactants. So add those together, tell me what you get. I beat you. Okay, so you should have got 1,920.5, is that right? Now, add this. And they should be very close. The mass of the reactants, the mass of the products. Did you already add it, Delaney?
I think you put the last number wrong. Was it 3?
Say, I'm sorry, say it again.
Is it 376?
Yeah, 376.5 grams.
It would be 1,924.
24? Ooh, that's a little bit off more than I thought. Is that what everybody's getting? 1,924? That's a little bit off. It's okay because it's way up there. It's almost 2,000, so being off by 4 is not very much. But normally they even come even closer than that. Did everybody get that number? So, okay, so at this point, I'm not sure what made me be off. We're off a little bit, but essentially we must have done it right because of all the numbers that could have come out to be, it's pretty close to 1,020. So I'll go with that. All right, what do you think? Yes. You have to work at this. I mean, once you catch on to this, it's like nothing. But if you don't do it and catch your mistakes, then every day you come in here, you're going to be the same place. All right, let's do shortcut. Okay, let's do shortcut. All right, now let's pretend that you don't know any of these numbers, okay? Let's pretend the whole thing's blank. And what if I tell you that all I want you to do is fill in these boxes and things like that? Let's use shortcut. We can do this whole problem in about 2 minutes. All right, here we go. We're going to start here as my given, all right? And when you want to go down in the mole world, what do? Divide by molar mass. What's the molar mass of lithium hydroxide? Let's do it. Use your calculator. Clear your calculator. Put 1,000 divided by 23.9. Are you there? That's how fast you could do it. When you go down the mole world, you divide by molar mass. I'm done. Now we're going this way. Ready? We're going this way. When you go sideways, you look at the coefficients. 2 has to go down to 1. Got to get smaller. 2's got to go down to 1. Now, you have a choice. Multiply by 2 over 1 or 1 over 2. Which one makes you smaller? All right, so multiply that in half. Put that on your calculator. Times a half. Ding, 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 ding. Watch now. Watch now. Here's the neat part. Watch. Look at the coefficients. 1, 1, 1, 5, 5, 5, 20.92, 20.92. Matchy, matchy, matchy. That's fast. The ratio, for every one of these, you have to have one of these. For every 20.92, you got, see, it's got a match, don't they? And now going up is easy. When you want to go up out of the mole world, what do? multiply by the molar mass. So ready? 20.92 times 44. Ding, ding, ding. 20.92 times 74. Ding, ding, ding. 20.92 times 18. Ding, ding, ding. And the only one that's tricky. The only one that's tricky with shortcut is up here. And what do you know? 1 mole of every gas as what? So if you take moles times 22.4, you get liters. That's a shortcut for that one. All right. I'm looking at your faces. What do you think? Oh, man. Okay, yeah. What are we thinking? All right, what I'm going to do, I'm going to change gears a little bit because I'm glad we reviewed. And I think some of you are getting better. Is anybody getting better? I think instead of giving me the quiz right now, I think what I'll do is there's a little bit of a lesson I can teach you, and that'll finish the period. And then when we come back on Wednesday, we can take the quiz the first 20 minutes of class, okay? All right. You can also, if you need to take this home and you want to say, I'm going to get another piece of paper out, I'm going to do it again, and watch me, I'll be able to do the entire thing by myself with no help. And if you can do that, you're going to get a great grade on the quiz. I'll give you a grade for the homework. Now, we can't do the back side yet. I haven't taught that yet. So what I want to do is, let's take a look at this. I want to teach you the last lesson. If you want to read in your book, chapter 9, the last 3 pages of the chapter have this thing. I'm going to teach it to you, and it's called percent yield. Now, I want you to keep your homework out because I'm going to use the homework as an example, okay? So keep that out, and let's talk about this thing here. In this world out here where people make money, many companies base their company on some kind of a chemical reaction. Whether or not they're making plastics, I think I told you about in Greensboro, they make the little pellets that go in diapers. Whether or not they make ethanol. Ethanol is what they sometimes put in gasoline to help it burn a little cleaner. Maybe you make medicines, and that's chemicals. You see that? The bottom line is, your company wants to know, we put this much money and effort into the making this. Can you tell me how much of our money was not wasted? Now, there are some things you can't help. You can't help but wasting money. You don't want to, but you have to. My car, for example, is only about 30% efficient. That means because I want the gasoline to be used to move my car down the road. But some of that energy is used to push air to the side, it's given off as heat, and it doesn't push the car down the road. And so what that means, every dollar I put in that gas tank, every dollar of gasoline, 30% of that dollar actually gets me to move down the road. And 70%, sorry, it does not move you down the road. So in the world out there of chemistry, percent yield is very important. And here's the definition of percent yield. I feel very confident that you're going to catch on this lesson very fast. You're going to catch on to this very, very quickly. Okay, now, here we go. I'm going to make up a problem for you, and we already did it. The good news, we already did it. Let's see. Joe actually did the experiment. Yes?
What does it say up there?
Oh, it says percent yield is actual yield over theoretical yield times 100. And I'll tell you what all that means in just a second here. Joe actually did this experiment, and he did this experiment right here. I'm gonna have him do this one right here, and he got 300 grams of water. What was his percent yield? Okay, so here we go. What's the definition again? Percent yield is actual yield. So how much did he actually get? How much did he actually get? Now, what could he have gotten in the perfect world? In the perfect world of no error, no waste, what could he have gotten? What's the most he could have gotten? Say it. Yes, 376.5. Is that right? So you figured out. What did you figure out here? What do you call these numbers on here? This is not actually doing the experiment. I didn't see you get any test tubes out or beakers. This is all theoretical, isn't it? This is the theoretical amount of lithium carbonate. The theoretical, you see that? You didn't actually do it. But when you actually did it, I made up a number, by the way. I made up a number, said Joe actually did this experiment and got 300 grams of water. But Joe, you know what you could have gotten at the most in a perfect world? You could have gotten 376.5. Now, you know why the only reason I multiplied by 100? I taught this to you before, but what is 0.5 in mathematics in percent? What's your teacher teach you to do? 0.5 is what? Don't you move the decimal over two places and say what? I lost you on that one. Okay, so your math teacher should have done this. What is 0.5 in percent? Isn't 0.5 the same as 1/2?
Yes.
Isn't 1/2 the same as what? Okay, here's what your teacher should have done. 0.5, if you move the decimal over two places, you get what? That's how you change a decimal into percent. Do you remember them teaching that? Oh, so this part of my equation is not mysterious. It simply says you're going to get a decimal, and I want to move the decimal place over two places, and that's what multiplying by 100 does. So if you do that, divide by that, times 100, you'll get the percent yield, and check your neighbor. Check with your neighbor, see what they got. What is the percent yield of this person? Do everybody see where I'm doing this? I had to make that number, didn't I? I had to say, hey, Joe actually did it, and he actually got this, but this over here told me how much he could have gotten in a perfect world. All right, what'd you get? Who's got it done? Layla, you done?
79.7%.
All right, you know what? That's not bad. It's not bad. It means that, hey, Joe, you were about 80% of perfection. You were about 80% of perfection. That's called percent yield. Now, that's how the real world works out here. I happened to, before, they don't do it anymore, they gave tours. There's a company, it's now called, it used to be called RF Micro Devices. And I took a class out there before. They don't do tours anymore, but it's now called Corvo. Anybody ever heard of Corvo? Believe it or not, right over there on Highway 68, pretty close to where I-40 and 68, everybody know where I'm at? There's a McDonald's there. There's a bunch of hotels there. Anyway, there's a company real close to that, and they're called Corvo. Now, Corvo is a multi-billion-dollar business. Now, what they do is they make things for cell phones. They're called amplifiers. And what that does is it makes your battery last longer. Everybody in the world wants that. Now, there are other companies around the world that want to build that too. So RF Micro Device is always trying to make their things better. They're called Corvo. Better and better and better. One thing, we went out there, this is almost 10, 12 years ago. They said that they use pure gold on some of their circuitry. Gold it conducts electricity so well, they use pure gold. Well, sometimes the gold would be maybe go down the drain, or it'd be in the form of gold ions that look like water. And somebody in that company figured out how to take their waste products and get the gold out. And it saved their company $1 million a year. $1 million of gold per year were saved by somebody who doing that. Now, what happens if another company didn't? They waste money, aren't they? So their percent yield, their bottom line is going to go higher and higher. And so if they can figure out a way to maybe have percent yield at 90%, what if I told you could do the same experiment and get 90% yield? And what if you're talking about a big company? And that's why they hire chemical engineers. Chemical engineer is one of the hardest engineering degrees to get, and you have to be a thinker. You have to know about math. And they're going to say, come to my business. Let me tell you everything we do to make this chemical. How we heat it up, how we cool it, how we do this. And look at my whole process and tell me how to fix it so we can get a higher percent yield. Now imagine a company that goes from 79.7 to 90% yield. And they do this all day long, okay? What if you saved that company $1 million a year? You think it was worth that $90,000, $100,000 salary you paid that person? I think so. Isn't that possible that person might even help you again, go from 90 to 93% yield next time? And it is hard. It's hard to figure it out. But percent yield is all about percent of perfection. What do you think? Are you okay? I'm going to give you another one. You try it. Let's say that somebody else does the same experiment, except, let's do, who can this be? Who do you want this to be?
Laura.
All right, Laura? Okay. All right. Laura got 1,200 grams of lithium carbonate. Okay, now find out Laura's percent yield. Okay, see if you can find Laura's percent yield. So Laura did the same experiment, except she wasn't looking for water, she was looking for lithium carbonate. And then when you get done, ask your neighbor what they got, and see if they match. Find somebody who's done and see if you match. What'd you get for percent yield? What'd you get?
Are we still using like the worksheet that we did?
And by the way, the experiment she did was the same one we just got done doing, okay? Everybody get that? So her actual yield was 1,200 grams. But you know what? That was not perfection. What was the theoretical? What was the theoretical amount of grams? Everybody look up here. 1,548. And again, we just multiply by 100, just simply move the decimal over two places. All right, did you match? All right, who'd you match with?
You get 77.5.
Did you match? Okay, Delaney, did you match anybody?
No.
Okay.
Left out a zero. I already did it.
Okay. All right, how about, you guys match? Okay, did you match? Did you guys match? May, did you match anybody?
Yeah, but
All right, so what's the number? I just made this up, so I don't know the answer.
77.5.
Ah, not bad. 77.5? So what do you think about percent yield? Is that pretty easy part?
Yes.
Okay. All right, so you're okay. All right, so what I'll do is we got a couple more minutes, but I thought you did well today. You seemed like you were paying attention well, and it seemed like you, maybe it's because I said you were going to have a quiz today. Should I do it every day? I don't want to do that. I don't act like you're going to pay attention because you have a quiz. I don't want to do that. I want you to pay attention because I want you to learn things. Here's what we're going to do. On Wednesday, we'll start out with a quiz. It'll be the same type of thing. We have to show you work down here. Use shortcut up here. Get that? Get that? Okay, and then I might throw in a thing called percent yield in there. Yes,
Will the yield thing be on the quiz?
I'm sorry, I can't hear you.
Will the yield be on the quiz?
If I put a percent yield on there, it'll be a bonus question.
Okay.
How about that? We gotta wait a couple more minutes, okay? Just sit down for a couple more minutes. I can't have you leave early, all right?
I'm sitting here.